All right. So, example number 4. Okay. So this one tells me that, again, I need to find lengths, and they need to be exact value, which means I cannot estimate or root or do any of those lovely things. All right, so we have this triangle here. It is a 30, 60, 90 triangle. PRQ. It tells me that this angle up here is 60 degrees. There's my 90 and my 30 degrees there. Okay. And they only tell me that this side is 4. And they ask me to find the lengths of RQ and PQ. No, this will be using special triangles. So what I like to do is I go in and I put my special triangles. I usually go in and put them on the inside. So I know that this is the square root 3 side, this is the 1 side, and this is the 2 side, right? So one way to solve these questions, right, is to and tan, if they are decimals, right, like if there's not a whole number, they're going to come out as a decimal, right? And then that's how to turn it back into radicals. So you're going to use for your proportions to do that. So you know that, and you can do it either way. If you want to go ratio over triangle, as long as you do ratio over triangle, right? Or you can go triangle over ratio. It makes no difference. So we're going to go 1 over 4. So in a right triangle, in a 30, 60, 90, that side's worth 1. It's currently at a 4. So if I want PQ, right, his ratio is root 3, and that. So if I cross multiply, PQ, right, is 4 root 3. Make sense? Yeah. And so then if I go the other one, this one's not as bad. Like if this is 1 and this is 4, then what does the hypotenuse, what does RS have to be if this is 2? 8. So some of them are easy to see, right? The square root one might not be. So we know that this, and we know that RQ is 8, right? Just because we can see that and notice that that is 8. So they may ask you, like, what is the perimeter? Right? What would you do if you wanted the perimeter? Right. 4 plus 8 plus 4 root 3. Remember, that's 12 plus 4 root 3. I want area. Base is right, 4 root 3 times by the height of 4 divided by 2 gives me 16 divided by 2 gives me an 8, square root 3. And this could be units squared and units. Make sure I've got sound at the right. Yep. All right, so there's that one. You have to be able to do that. All righty. And you should be able to, so this is example 5. Find the exact values. Right? So there's going to be 4 of them. I'm going to put 4 of them up here. One is a review from last year, so we know what we're talking about. And the other ones are the 3 new combinations that will be given to you. I'm just putting 4 questions. So this is the PC21, and then these are the new ones. New, new, and new. So the old one would be like something if I said sine 150 degrees. A new one would be me throwing in a negative. So tan negative 135 degrees. So this would be your negative. Another new one would be your coterminal ones. Coterminal. So like, oh, just one second. I'm going to move this one. One would be the new 6 trig one. So like cosecant 315. All reciprocal trigs. And then this one would be your terminal, which I'm going to put as also a reciprocal trig, 1125. So those are your 3 combinations now, 3 other combinations that are expected at a PC 30 level. So, again, where do we always start with any of these questions? With a picture. 150. Right? I need to know what triangle I'm going to be using. So sine 150, that puts me in quadrant 2. That means this is the 150. That leaves me with what left over? And we'll zoom in. You can see it a little better. So, and again, I'm going to label my triangle. There we are. Square root 3, 1, and 2, depending on what angle I want. And I also need my little cast rule. C-A-S-T. So sine is positive in that quadrant, so I will have a positive answer. And I will do sine of 150. Well, sine of that is 1 over 2. Yes, I guess is usually not an answer. That's one of those, I'm fine. Are you? Are you really fine? Yes, perfect. So if I threw in negatives, what would be the only change that you would do? What does a negative mean? Got to go the opposite direction, right? So instead of being 135 in quadrant 2, 135 is now in right, quadrant 3. 180 minus 135 is a 35 triangle, right? According to the cast rule, we're okay. Tan should be positive in this quadrant, so I don't have to worry about that. And tan, and again, label your triangle. 1, 1. I don't really care about the hypotenuse because I'm using tan. So it's a 1, and since it's positive, I'm done. Divided by 1 gives me 1. Okay? Cosecant, 315. So where is 315? Quadrant 4. So if that's 315, what's left over? 45. So again, I'm looking at a 45, 45, 1, 1, root 2. Cosecant is the opposite of sine. So is this going to be positive or negative in this quadrant? So let's put a negative on it right off the bat. And since cosecant is the opposite of sine, and sine theta is equal to opposite over hypotenuse, I'm looking for right, hypotenuse over opposite. So hypotenuse, 2 over 1, do I need the 1? No, done. And the last one there, Grady is doing some calculations. What do you know, Grady? He's dividing by 360, and what do you got? Good. So he knows there's 3 revolutions. So 3 revolutions, 3 times 360. What is 3 times 360? $1,080. So this is the 3 revolutions that you need to take off, right? So we can get down to our, so take off the 3 revolutions. And what do we got? 5, 4, a 45-degree angle. Right? A 45-degree angle. And I'm going to be in quadrant 1, because 45 degrees, if that's what I have, we're going to be in quadrant 1 at 45 degrees. And everything's going to be positive there. 1, 1, root 2. So secant, again, is the opposite of cos theta, and cos is adjacent over hypotenuse. So I'm looking for hypotenuse over adjacent, which is root 2 over 1, which is root 2. So there's your 4 combinations there. Okay? So that's all exact values. Now, the last thing that you should be able to do is the thetas. So calculating angles. And there's a few yet. Calculating angles. All right. So this one is going to be you need a calculator for. All right. So let's do the different types of calculations. Okay, there is 5 of them. I would make sure that we write all the steps to them, because then you kind of remember, because there's kind of some different orders of things that have to be done. All right. So type 1, maybe I'm gonna, no, I'll just go A. Type 1 is just this is the old. I'm gonna just put old. This would be things like sine 119 degrees. Right? How do I calculate sine of 119 degrees? Type it in your calculator. What should you be in your mode? degrees. So make sure your mode is degrees. So just, all right. This one, we just type it in the way it is. There's no actual mode. Yep, we're good. So sine 119, we'll go 5 decimal places. That is 0.87461. All right. So that's fine in going one direction. So the old one would be for, let's say that I had cos theta is equal to a negative decimal 41040. So this time, I'm finding it's giving me that 87461 and they want me to go backwards, right? Those are the opposites. So how do I get theta by itself? Exactly. So I'm going to go cos to the negative 1 of negative 0.41040. Cos to the negative 1 of negative 0.41040. Right? Now, depending on what it's asking you for here, when you do that, you're going to end up with 114 degrees, right? Which is what we want. If I was wanting the reference angle, right? If I wanted the reference, I would subtract it from 180, depending on the calculation, but this is what I want, all right? So there's the two calculations from the old time. So let's throw in some new stuff. So the first one would be like negatives. I'm going to go over to this side. Here's C. New. What happens if I have, so this is the old, what happens if I got a negative? Do you think it's going to change what I do? No. So that could be something like tan negative 242. All I'm doing is putting a negative on. Tan negative 242. Doesn't change what I do. Gives me a negative 1.88072. Negatives don't change anything. It's the reciprocal ones that we're going to have some issues with. Okay? So we've got when we have the angle and when we find an angle. So let's go with D when they give me the angle. So like cosecant 230 degrees. So because our calculator does reciprocal, right? So what is its reciprocal one? Sine. Sine. And since it's a reciprocal one, cosecant is the same thing as me going 1 over sine 230 degrees. Okay? It's the reciprocal trig ratio. So I'm going to take my thing, rewrite it in its equivalent form, which would be 1 divided by sine 230. 1 divided by sine 230. And I'll get a negative 1.30540. Good. Okay. Now, when we had the angle, we did the whole thing as a reciprocal. Okay? So when we have an angle, so when we're finding an angle, right, so let's say that I'm going to go cotan theta is equal to a negative decimal, oh no, sorry, this one's positive. It's looking in the wrong spot. Here we are, cotan, 0.03492. In the last one, I did the reciprocal because I'm typing the whole thing into my calculator, right? This time they've given me what the answer is in the calculator. They want me to find the angle. So again, I'm going to change this from cotan to its reciprocal one called tan. But you notice I don't flip this guy. I go and I flip my answer. Okay? I'm going to go over and I'm going to flip up I'm going to do the inverse, or the reciprocal of my answer. That's the difference. Then I'm going to calculate tan, use tan to the negative 1 of 1 over 0.03492. And that will give me my angle. The angle, you just 1 divided by sine of that angle. But if you're trying to find the angle, change it to the one you know. You can calculate the calculator and flip the answer. And then punch it in. That should give you an 88-degree angle. Is that what we got? Good. So this is your new. All right, and you got them in there, so you can refer back to them. All right, so here's the stuff. That was just calculation. This is what you would do with it. All right, I'm going to flip the page. Are we good? I know this one has a lot of examples, but it gives you a different combination of things. All right, let's see what we want. I like this one. All right, so this would be an example of one. What are we at? What number are we on for examples? 6? Okay. Example 6. All right, says find all values of theta between 0 and 360 degrees. So again, they could have written it as that little, domain thing, but they didn't. They just wrote it like that. For which tan theta equals negative 1.23456. Okay. That is the question. So find me all theta values between 0 and 360 for where tan is equal to. So this is, right? This is a PC 21. This is just reviewing what we did. Exactly. 0 equals 10 to the negative 1 of negative 1.23456, and that will give us our angle, right? Second function 10, negative 1.23456, and that gives me a 50.99, and a lot of times it'll give me a negative. Now, again, your calculator doesn't know what it's doing, right? It's just calculating the math of it. So it doesn't tell me that it's a negative angle, because it tells me it's 0 to positive 360, right? It's not going 0 to negative 360. So I know it's a positive theta value, right? And this tan is negative. So where is theta actually located? Because your calculator gave you, could be a reference angle, or it could be an actual theta degree angle if it's in quadrant 1. How do I know where I am? 2 and 4, right? According to the CAST rule, C-A-S-T, and tan is negative, I have to be in these two quadrants. Right? So that tells me that one angle is that big, and the other angle is that big.
Two angles?
Yes, because it's asking you to find all values of theta between 0 and 360. So always, if they don't tell you what quadrant it's in, there's always going to be 2 positives and 2 negatives. Tan is positive in this quadrant, positive in that quadrant. And since my answer question started out negative, they're asking for the theta values that are there. So does that negative on the 50 mean anything? Not really. It just tells me that my reference angle is 50. That's 50, and this is 50. So this is my reference angle. So one of them is going to be 180 minus 50 at 130. And the second one will be 360 minus 50 at 310. There's my answer. I think I only have one more. Yep, that's all it. One more. So if that's the PC21, let's do the PC31. Which means I'm going to throw in a reciprocal trig function. Okay, it's going to look almost identical. Last example. All right, they're telling me that is find the third quadrant angle, theta, if secant theta is equal to a negative 4.25889. So this time, right, they tell me exactly where it is. It's in the third quadrant. So I know my answer has to be between 180 and 270, right? It has to be something that looks like that. All right? So, how do I tackle a secant theta when I have that? Right? This is like which one? Is it a D or an E? E, right? So according to this, I change it to the primary one, flip my answer, and then do the tan to the negative 1 or whatever it is. All right. I'm going to change secant to cos, which then moves 1 over a negative 425,889. Then I'm going to go cos to the negative 1 of that answer. Second function cos, 1 divided by a negative 4.25889. Delete. And I get 104. Is that my answer? Reference angle? It's the theta angle, but not the theta angle. Is it the theta angle I actually need?
What does that even mean?
Oh. Theta angle, the standard position angle, is an angle that would go from the x-axis all the way to this line.
So why would you not use that?
So, and I'm looking at this. So reference angle, if it had popped out the reference angle, it would have given me an angle that was less than 90 degrees, which would have been this angle right here. Punch that thing in without the negative. Reference angle, right? Remember that from
So don't put it in there?
don't have, like, if you put it in, just be aware of what it's doing. So that's why I draw a picture. Where is the 104 in this picture? Can it be all the way around? Is it the reference angle? No, it's this angle here. It gave me this angle right here. This is the 104. If you take out the negative, you'll get the, what is it? Right? So if I go in and do the exact same thing, close to the -1 of 1 divided by 4.25889, I get a 76. That's the reference angle. Okay? It's negatives because of the cast rule, right? Because is this thing negative in this quadrant? Yeah, tan's the only thing that's positive in that quadrant. And remember, reference angles generally are not negative, so it gave us the other angle. So now, how am I going to use this 104 to get me the actual angle that I want? Exactly, from?
360?
Yeah. So now I'm going to go, so this is not even the angle that I want. I want 360 minus 104, all right? Because I need an angle that's somewhere between 70. Well, 104 is not. I get a 256-degree angle. Is that an angle that makes sense in that quadrant?
Yeah.
Yep, there's my answer. Okay. That is everything. You can finish the entire thing now. Yep. You can do it all.
Do we need to move?
Yeah. I'm gonna do this one too. Yeah, you can do everything now.
Why are we stuck to me?
Okay?
Usually I say my stuff goes,